Welcome to Virtual Process Control Laboratory. I am Professor Uttam. Today we will discuss about pressure control of a system. Now there is a symbolic compressor with a piston which will move forward and backward. As it moves forward, it is a discharge stroke. When it is backward, it's a suction stroke, and air enters through this port, and this suction valve opens. This gets closed with the discharge valve, and then when it is pushes forward direction, then it is compresses. This valve closes, and this valve opens, and this way pressure is developed and enters through this drum or pressure vessel, where the pressure rises up to maximum 70 kg per centimeter square, and the pressure which is connected with a pressure gauge and a transducer, which is a pressure transducer which converts into electricity, and this current equivalent pressure enters the controller, which can be which calculate the required set point or desired pressure with the measured value of pressure. And if you press auto, it will drive this control valve. It shows this valve stem is fully open now, that is normally open valve. Pressure is applied and power is applied, it will close, otherwise it is open. So this action will be taken when this gas valve is fully open, so that you need not bother to open and close this manual operated valve. Now I will show you the start. As you press auto, you can see that it is showing that this valve must be kept open, that as and when necessary pressure can be measured, and say we want to keep it as 10 as the pressure, and the valve is kept open, but this control valve is now checking the gas to maintain the pressure inside the vessel. So you can see that it is rising now. So it is around 10, and if you want to change it, it will take time, no doubt. So you can properly tune this controller. So it is a reverse acting, that power to close the valve. So as pressure is more than the set point, it applies, that is, it keeps this valve open, that is, power is reduced. So increase, decrease, decrease, increase. Similarly, the reverse direction. So we are setting reverse acting. Now you press it for proportional band 100, and bias value is 10, and reset value is 0, means it is proportional control. As we have seen that in proportional control there is some offset, and so we can change it. Say we make it as 0.1, it's a PI control now. Now press tune again, and the red value is 0, so it is simply PI control. Address is 1. Now set point will be quickly achieved at 10. It is exactly 10 it will be. It is hunting because a lot of changes has taken place. So set point is going to be 10. So it is 10. We can make it as 20. So quickly it turns to 20, and because of PI control. Initially it was proportional control, that's why there was delay, and difference was left as an offset. Now there is no offset. Now we will go on increasing it 30. You see it is 30. Then it is, you can make it is 40 or 45 as you like, 40. So you can make it as 50 or 60, you can say 60. So you can set up to 70, but you can avoid that to exceed 70. The vessel may be in trouble. So we can make it as 65 or so. So we can reduce this value. If you suddenly give a wide difference, there will be wide fluctuation. Now make it as say 30. So you can see there will be some fluctuation. So make it as 30. You can see the pressure gauge reading as well as controller reading is widely fluctuating because the change in set points are wide. Otherwise, ramping algorithm should be used. That is, step by step, we should have used it to change the set point. Instead, we have widely changed it. So to reach 30, it will be disturbing, but it will reach ultimately 30. So it is working above 30 and below 30. Now it is 30. So finally it is settled at 30. Now you can see the recorder. View plot. So there are many so many fluctuations that we have seen earlier, and now you can press it for the final or the last reading, which I have made it as 30. I have to wait for some time because every 100 seconds it records. So this is the final result for the last 100 seconds. I see it is 30, the red line is fluctuating and it finally settles with this blue line, that is set point. You can go back to the system. Now it is 30, exactly 30. So if you want to make it as 40 or 50, and then press the recorder again and view plot. It will take time. Now it has shown that 50 has been reached. The blue line is the new set point and red line is the PV value which has maintained it. If you view plot, then you will see that blue line will continue, and now we're back. So this is all the effect for this automatic control system of a pressure drum. And if you try to control with the help of this manual operated valve, it is quite difficult because the valve is large and people has to run to see what is the pressure in the gauge and then open and close it. Is quite cumbersome, but with the help of this controller, if it is properly tuned, can be utilized for controlling it very smoothly. And we have noted down that there is a control valve, especially it is a diaphragm operated valve, and this signal is pneumatic signal. Obviously the controller produces electrical signal which has to be converted into pressure signal. There is an IP converter which is not shown here, which drives this pneumatic valve. It may be motor operated valve also, as we have seen in the liquid flow rate evaluation. And one more thing is missing here. There should be a pressure safety valve which should be added here, because in case the pressure goes above 70, then the pressure will be released to the atmosphere or to the flare or some stack for a safe disposal. That was not shown. I hope you have understood this control system of a pressure in a vessel. Thank you very much for observing this video.